I welcome you to our week 7 online facilitation of the course PHY 205. That is Introduction to Space Physics. This week, we'll be looking at modern cosmology. Modern cosmology. Okay, sorry, trying to fix this. Okay, we'll be looking at modern cosmology. And so as a way of introduction, when we say modern cosmologists base their theories on astronomical observations, physical concepts such as quantum mechanics, and an element of imagination and philosophy. Okay, hope you know philosophy. Philosophy is actually a combination of two words, philos and sophia. Philos means love, and sophia means wisdom, love of wisdom. So, okay, so the objectives of this unit. One, at the end of this unit, the student is expected to be able to explain the Big Bang theory. We're expected to be able to explain the Big Bang theory. You should also be able to explain the steady state theory. And then you should also be able to understand the future of the universe. The Big Bang theory is part of the origin of the universe, and you should be able to explain the future of the universe. Okay. Modern cosmologists have moved beyond trying to find the Earth's place in the universe to the explaining of the origins and the nature of the universe. Okay. Okay, let me try to. The current standard model of the origin of the universe, called the Big Bang theory, proposed that a major event, not unlike a huge explosion, set free all the matter and energy in the universe and started its expansion. Are we together? The Big Bang theory states that the Earth was formed from a major explosion, or the universe was formed from a major explosion of whose origin was unknown and is still unknown. Now, theories of the evolution of and fate of the universe go on to describe a universe that has been expanding and cooling since the Big Bang. Now, early versions of the theory held that the universe will keep expanding forever or eventually collapse back to its initial state, an extremely dense object that contains all the matter in the universe. Okay, that's when the Big Bang theory was developed in the mid-20th century. Some cosmologists found the idea of a sudden beginning of the universe philosophically unacceptable. They proposed a steady state theory, which said that the universe has always looked more or less the same as it does now, and that it does not change over time. The steady state theory could not explain the background radiation. That is part of the limitation of the theory, of the steady state theory. It could not explain the background radiation. Okay. So let's look at the Big Bang theory. The Big Bang theory describes a hot explosion of energy and matter at the time the universe came into existence. This theory explains why the universe is expanding. Okay, do you understand what I'm saying? The Big Bang theory describes a hot explosion of energy and matter at the time the universe came into existence. So this theory explains why the universe is expanding. Recent versions of the theory also explains why the universe seems so uniform in all directions and at all places. Okay, it says the recent versions of the theory explains why the universe seems so uniform in all directions and at all places. The work of Edwin Hubble, I know you remember or you can check the Hubble expansion. It was proposed by Edwin Hubble, which showed that the universe is expanding, led cosmologists to begin tracking the history of the universe. The dominant idea is that the universe will have been hotter and denser billions of years ago. The current calculations based on Hubble expansion place the age of the universe at about 13.7 billion years. They also hypothesized that some radiation that remains from the Big Bang explosion may still be may still be circulating in the universe. So we've considered the Big Bang theory. Let's try to see what the steady state theory is all about. In the 1940s, British scientists Herman Bondi, Thomas Gould, and Fred Hoyle were philosophically opposed to the requirement that the Big Bang theory put forth for the extreme conditions in the early universe. Now, the Big Bang theory was framed in terms of what they call the cosmological principle, that the universe is homogeneous, the same in all locations, and isotropic, looks the same in all directions on a large scale. Okay. So the future of the universe now. A fundamental issue addressed in cosmology is the future of the universe, whether the universe will expand forever or eventually collapse. The first case, as the external expansion, is known as an open universe. And the second case, the eventual collapse, is known as a closed universe. So if I ask you to differentiate between an open universe and a closed universe, you should be able to explain that. One is based on expansion, eternal expansion, and the other one is based on the eventual collapse. Now, a closed universe will require sufficiently high density to cause gravity to eventually stop. The universe expansion and begin its construction. Let me take that again. A closed universe will require sufficiently high density to cause gravity to eventually stop the universe expansion and begin its contraction. Such a collapse will require a deviation from Hubble's law. So observational cosmologists try to observe the distances between very distant galaxies and and Earth using methods other than measurements of redshifts. The scientists can then compare these distance measurements with the galaxies redshifts to see if Hubble's law holds or not. In the late 1990s, astronomers compared the redshifts of supernovas in distant galaxies. Surprisingly, distant supernovas were slightly fainter than had been expected. This result was tentatively interpreted as an acceleration of the expansion of the universe. Astronomers were so surprised by the suggestion that the universe might be accelerating its expansion that they attempted to find out other explanation for the relative dimness of distant supernovas, such as absorption by dust. Okay, by a few years into the 21st century, however, these other conceivable explanations had been ruled out, and the accelerating universe concept became widely accepted. Okay, so this would be the self-assessment exercise. Discuss how modern cosmologists base their theories on astronomical observations. Discuss how modern cosmologists base their theories on astronomical observations. We are expected to do that. And report back. Conclusion. This unit focuses on modern cosmology. We learned that modern theories of the evolution and fate of the universe go on to describe a universe that has been expanding and cooling since the Big Bang. In summary, we learned that modern cosmologists base their theories on astronomical observations, physical concepts such as quantum mechanics, and an element of imagination and philosophy. Okay. Then the current standard model of the origin of the universe, called the Big Bang theory, proposes that a major event, not unlike a huge explosion, set free all the matter and energy in the universe and started its expansion. Okay. Now, the next summary is that the steady state theory says that the universe has always looked more or less the same as it does now, and that it does not change over time. So we are going to look at the next unit. Under module 3, which is space law. Space law. So as a way of introduction, international law arises from several sources, chief among them being treaties and custom. Now, treaties seem an obvious example to the casual observer and can be enacted bilaterally between two nations or multilaterally between several countries, often with the assistance of the United Nations, UN. They are signed formal legal documents. That's the space law. They are signed formal legal documents. However, custom was the first player and still an important one in creating international law. custom is defined as the general principles of international law, not embodied in any treaty, but observed and considered binding by civilized nations. Okay, let me take that again. Custom is defined as general principles of international law, not embodied in any treaty, but observed and considered binding by civilized nations. Now, the objectives of this unit is that at the end of this unit, the student should be able to, one, explain the following space treaties. A, should be able to explain the rescue agreement. You should also be able to explain the moon agreement. And then the student should also be able to understand the registration convention. Should also be able to understand liability convention, the registration convention, liability convention. Oh, the limited test ban treaty, the student should also be able to understand that. And then the outer space treaty, which is OST, outer space treaty. All these are expected that the reader, that the student taking this course should be able to explain this. So if I ask you during the exam, you should be able to explain this clearly. International law. International law seems a vague and nebulous topic at best, and certainly appears to lack apparent enforcement mechanisms. Unlike violating the civil laws of a nation, there are relatively few expressly defined punishments for violating international law. Economic sanctions and embargoes are largely of symbolic importance, and certainly arresting the offender. Usually, an established nation, well equipped with armies and munitions, is impossibility. Two, thus, nations are faced with unclear guidelines and unenforceable punishments that govern their interactions. But yet, more times than not, nations abide by the rules of international law. There are several reasons for this, as well as reasons for breaking them from time to time. They include 1A, a system of international law. A system of international law is in the general interest of all nations. It permits business to transact, travel to take place, and cooperation to ensue in health care areas. Okay, then B, cooperation among nations is imperfect because humans are involved. Humans tend to forget what was agreed upon from time to time, but the formality of a treaty helps to solidify what was agreed upon and served as a base for negotiating good and bad faith disputes that may arise in the future. C, nations gather their own interests and will violate international law application. Usually, this is done very selectively, or else the offending nation faces isolation from the rest of the world for crying wolf too many times. For crying wolf too many times. So where does space begin? Now, when we are looking at space, we are saying where is space? Now we're looking at where does space begin? One of the first problems early formulators of space law faced was the definition of where space began. How far up from the Earth's surface did an object have to be located to be considered in space, and thus subject to the laws for that arena? They considered first the von Karman line, an altitude approximately 53 to 62 miles above the Earth's surface, where aerodynamic lift is largely non-existent. This will be the general boundary of airplane flight, and thus air low and a semi-logical point at which to start the domain of space law. They also considered that below an altitude, they also considered that below an altitude of 69 miles, sustained orbit is practically impossible. Yet there are violations of these generalizations. Okay. Now, the X-15 classified as an airplane flew an altitude higher than 62 miles, and satellites have orbited at certain points in the orbit lower than 62 miles, 69 miles. So the definition which has evolved is as follows: any object that is in orbit about a planet is said to be in space. Okay, these definitions fall under custom and has never been explicitly delineated in any treaty or other official documents. Since there is no tangible black letter definition, there is a possibility that the current custom of defining in space may change in the future to suit the needs of the subsequent generation. So you can see that understanding where space began or begins remains what? An issue in the international law. It's an issue in the international law. So where we feel that the definition of in space is now, with time we believe that it will change as the needs arises. Now consider the predicament of an aerospace plane, like the Reagan proposed Orient Space Express. It will be both an airplane and a spacecraft. So will its passengers be considered astronauts and treated like envoys of mankind, as astronauts are considered under the rescue agreement? Highly unlikely, that is. Okay. This is just an example of some of the challenges that might lie ahead in the definition, or choosing not to define clear boundaries for where space begins. So the space treaties. The first one is the Limited Test Ban Treaty. Perhaps the first treaty to place guidance on the international norms of behavior in space was Limited Test Ban Treaty of 1963. The treaty prohibits the explosion of nuclear devices in the oceans, in the atmosphere, and outer space. The US, UK, and the Soviet Union signed this treaty. Other nuclear powers, such as France and China, did not sign the treaty. Though on the surface, this treaty may seem to be aimed at slowing down the nuclear arms race, it actually didn't accomplish that at all, as nuclear tests continued extensively underground by the US and the USSR. From a space point of view, though, it was extremely critical to ensuring the success of future satellite missions. Nuclear explosions in space propagate radiation and electromagnetic pulses. Okay, so you can see the reason why the limited test ban treaty is very important. Nuclear explosions in space propagate radiation and electromagnetic pulses, which can effectively kill all satellites within a distance of explosion. Previous explosions at high altitudes caused extensive damage to satellites, electronics on the ground, and created an artificial radiation belt that apparently persisted for years. Now, the Outer Space Treaty, OST. This is the treaty on the principles governing the activities of states in the exploration and use of outer space, including the moon and other celestial bodies. This was entered into force on October 10, 1967. The Outer Space Treaty has been ratified by 95 states, signed by 27 others. Now, the Liability Convention. This is the Convention on International Liability for damage caused by space objects. This was entered into force on September 1st, 1972. It has been ratified by 80 states and signed by 26 others. This is a major space law agreement that fleshes out liability provisions laid out in the OST. The OST is the Outer Space Treaty. It applies to both military and civilian space activities. 3. Rescue Agreement. This is the agreement on the rescue of astronauts and return of astronauts and the return of objects launched into outer space. This was entered into force on December 3rd, 1968. It has been ratified by 85 states and signed by 26 others. This treaty suggests that astronauts are the envoys of mankind and encourages nations to treat them as such. Okay. The next is the Registration Convention. The Registration Convention. This convention is actually the Convention on Registration of Objects launched into outer space. It was entered into force on September 15, 1976. It has been ratified by 40 states and signed by 4 others. This treaty requires all launching states to keep a registry for objects launched from their territories or under their supervision and report this registry to the UN from time to time. Okay. The Registration Convention is the Convention on Registration of Objects launched into outer space. It was entered into force on September 15, 1976. It has been ratified by 40 states and signed by 4 others. This treaty requires all launching states to keep a registry for objects launched from their territories or under their supervision, and report this registry to the UN from time to time. The next one is the Moon Agreement. The Moon Agreement. This is the agreement governing the activities of space. I said this is the agreement governing the activities of states on the moon and other celestial bodies. This was entered into force on July 12, 1984. It has been ratified by 9 states. When I say states, I mean countries, and signed by 5 others. The rules against extension of sovereignty to outer space and celestial bodies resolved a good deal of confusion regarding such matters. So your self-assessment exercise will be, what do you understand by the term space, and where does space begin? What do you understand by the term space? And where does space begin? Conclusion. In this unit, we have discussed the various international space laws and treaties. We also looked at space and where it begins. Says we discussed the various international space laws and treaties. I believe you can list all of them. And we also looked at space and where it begins. Summary. In this unit, we have learned that international space law arises from treaties and custom. In summary, in this unit, we have learned that international space law arises from treaties and custom. But we can differentiate between treaties and custom of international law, not embodied in any treaty, but observed and considered binding by civilized nations. 3. A system of international law is in general interest of all nations. It permits business to transact, travel to take place, and cooperation to ensue in healthcare areas. Okay, so you have a clear understanding of the space law. If I ask you any question on space law, you should be able to answer. You should be able to list all the treaties and the customs. You should be able to differentiate customs and treaties. So wish you all the best. See you next time. Best wishes.